So we're completing today the 2.6 notes that we started on Wednesday. And again, we started by factoring the sum and difference of cubes. What's meant by that? Can you give me an example of a cube? Give me an example of a cube. What do you mean by that? Is 2 a cube? Yeah, these have to be what are called perfect cubes. 2 is not a perfect cube. What is a perfect cube? Give me an example. 8 is because it's 2 times 2 times 2. It's 2 cubed.
27.
Same. 27 is because it's 3 times 3 times 3, 3 cubed. Yeah. So they have to be numbers like that. And when they are, we can factor them, and it's either the sum or difference. And we kind of discovered this with the calculator on Wednesday. Remember, it factored it for us. But it's a binomial, meaning 2 terms, and then a 3-term trinomial. Okay? And it was the cube root of these, and it was the same sign. And that's where the SOAP, we say we SOAP this. The SOAP comes from the same sign. And then it's this guy squared. So whatever you had here, square it. Multiply the 2 guys together and do the opposite sign. Always positive, and then it was the last term squared. So it's the squared, the product, the square of the 2 terms. Okay? Same, opposite, always positive. And that's where we got this little SOAP acronym. Same sign as what you started with. Opposite sign is this, and then always positive. Okay, so we did a bunch of factoring. We listed a bunch of perfect cubes, just reviewing all that. And then all we're going to add now is solve. And it's pretty simple. If I asked you to solve, and let's review the factoring as we solve here now. So if I asked you to solve and find both the real and the imaginary solutions, okay? So you've already done the right and factored form part. We're just going to find the real and imaginary solutions. Or you might see zeros, or you might see roots. So put /zeros/roots. If they say any of those things, you do it this exact same way. Okay, so we're going to do 2 of these. First one, let's start with f of x equals x cubed minus 8, and actually, you know what, it's going to jump right to equals 0. It's not going to have the f of x equals. It's just going to say x cubed minus 8 equals 0. I can't erase that right now, so we'll just put equals 0. Okay, so first thing you're going to do is you're going to factor this. And do you see that it's the difference of 2 cubes? Okay, and so the factoring of x cubed minus 8 is first a binomial and then a trinomial. Keep writing equals 0 on the other side. All right, who wants to try this for me? Who will factor this for me? Any volunteers? All right, thanks, Celeste. You want to do this for me? Go ahead. She didn't really volunteer, but okay. X minus 2. What is it? Okay, somebody want to pick it up here? What comes next? Jason? X squared. That's all you know. Okay. Katie? Plus 2x. Plus 4. Okay, so let's check that. X minus 2, it's the cube roots of each of those. Okay. Same sign. Opposite sign, always positive. Got the signs right. This is this guy squared. This is these 2 guys multiplied together, opposite sign. And this is the last term squared. Yeah. Okay, now for the solutions, you guys, we've got this factored. And I told you yesterday this never factors. This guy never factors, so don't waste your time trying to factor him. Okay? The solutions then, if I have 2 terms multiplied together equals 0, one of them must be what? Has to be 0, right? That's that 0 product rule. So I'm going to set each of these equal to 0. I'm going to take x minus 2, set it equal to 0, and then I'm going to take x squared plus 2x plus 4, set it equal to 0. This is just like what we were doing on 2.5. Okay? So you'd solve this, x equals 2. That is your real solution. So when it asks for the real solutions, that's the real one. That's the real solution, the real zero, the real root, whatever they ask, however they phrase it. Okay? This one's going to give you the imaginary ones. And guess how we're going to do it? How are we going to solve this? Quadratic formula. This won't ever factor, so don't waste your time. Let's just go right to the quadratic formula. What's the A in this case? 1. What's the B?
2.
And what's the C? Okay, so here we go. It goes x equals negative b, or the opposite of b, plus or minus square root b squared minus 4 times a times c all over 2a. Got to know that. Put it on a flashcard. Sing it in all the different versions that we know. Okay, whatever, so you can get it memorized. All right, so we got x equals the negative 2 we're going to leave. Let's figure out what this would be. 2 squared is 4 minus, put that minus in right away. Okay, then we have 4 times 1 times 4 is 16. And then 2 times 1, of course, is 2. So we'd have negative 2 plus or minus root, what? What's 4 minus 16? Negative 12 all over 2. At this point, can I cancel a 2 out of everything? Not yet, right? Because it's got to be outside the radical. Don't pull it out from under the radical yet, okay? Simplify the radical first. Okay, so I know I'm going to have an I because of the negative, so I'm trying to simplify root 12. Can you think of 2 factors of 12? Give me one that's a perfect square. 4 is, right? 4 and 3. And then this is the idea. The square root of 4 is 2. Square root of 3 I can't do. So I'm going to pull the root 4 out, and then I have the I out, right? And then I'd have root 3. Is that good? Square root of negative 12 becomes 2i root 3. Now can I cancel? Yeah, and I'm just left with what? What would be first? Negative 1 plus or minus I root 3. Those are the imaginary solutions. The imaginary ones are going to have the i's in them. And there's 2 of them there, okay? You got negative 1 plus I root 3 and negative 1 minus I root 3. Okay? One more of those. Think you guys got it? We just do one more. I want to do one where you have a GCF first with an x in it. Okay? So number 2, let's say the function is 2000x minus 2x to the 4th. 2000x minus 2x to the 4th. Okay? See, these aren't perfect cubes, so I'd immediately be a little suspect. Okay? Which means I probably need to pull something out first. What can I pull out of both 2000 and 2? First of all, what do each of those have? A 2. And then we also can pull out an x, right? Okay? So I pulled the x out. This would be 2000 divided by 2. What's that? 1000. Okay, and then here if I divided the 2 out, and then if I took one of the x's out, I'd still have x cubed. Oh, and this is supposed to say equals 0. Sorry, throw that equals 0 in. Okay, and then hopefully you recognize that this right here is the difference of cubes, and then you're thinking soap. I need to soap. Okay, so when I soap, I set up a 2-term and then a 3-term, either a binomial or trinomial. Okay, now what goes here? The cube root of that. What's the cube root of 1000? 10, right? That's 10 times 10 times 10. Same sign. X, the cube root of x cubed is x. Okay? This first term is the 10 squared, right? 100. Then you multiply these 2 together and change the sign. So plus 10x. Always positive. This guy squared. Okay. Then what we would do is we'd set each of these, there's 3 factors now. Because we had this GCF out in front, there's 3 things we're going to set equal to 0. Same thing, if you have 3 numbers multiplied together to equal 0, one of them has to be 0. So I'm going to set them all equal to 0. So 2x equals 0 is one of the solutions. 10 minus x equals 0 is a second solution. And then this one, which actually I would rewrite this. Ultimately, I would switch the order on this because we're going to have to use a quadratic for this guy. This will give us the imaginary solutions. Let's solve these first. Divide by 2. What's 0 divided by 2? 0. Subtract the 10. and then divide by a negative. So my two real solutions, are 0 and 10. X equals, I should have written. Those are the real ones. Okay, now we're going to find the imaginary. And if this was negative, I'd move it over to the other side, but it's not negative, so I can just reorder it, right? I want to keep it on this side. I want to keep everything positive. So if I just rewrite this, putting it in descending order, because then it's easier to see what A, B, and C are, right? Okay? Quadratic goes x equals negative b, right? The opposite of b would be negative 10 plus or minus square root of b squared minus 4. My a is 1. Since I'm kind of running out of room, I'm not going to write that because anything times 1 is equal to itself, times c, 4ac, all over 2a. Okay? So I'd have x equals negative 10 plus or minus the square root of 100 minus 400. So I'd have negative 10 plus or minus the square root of, what's 100 minus 400? Negative 300. Can I cancel a 2 out of everything yet? No, not yet. Got to simplify this. I, square root of the negative is going to be I, right? 300, can you think of the biggest perfect square factor of 300? 3 times 100, right? And just do then, what's the square root of 100? 10. That would come out. 3 would stay under. So I'd have negative 10 plus or minus. The 10 comes out, but what else comes out here? I, right? 10I root 3 all over 2. Yeah? Okay, now can I cancel a 2 out of everything? Yeah, what would be left? Perfect. Negative 5 plus or minus 5I root 3. Those are the imaginary solutions. Okay, so that's what you're going to be finishing on just, I think, like 5, the last 5 of that worksheet, or 6, maybe 6. Okay, so you're going to have 6 of those. Now, we do need to go ahead and go on.